See, this is an electrolyte. Electrolyte is the substance which is getting dissociated into ions. The positively charged ions are called cations, and the negatively charged ions are called anions. There are some electrolytes which will not get dissociated completely. Suppose if you take acetic acid, acetic acid becomes acetate ion and H plus ion. The acetate ion and the H plus ion will combine again to form undissociated acetic acid. Such electrolytes are called weak electrolytes. The electrolytes which get dissociated into 100% dissociation, they will get dissociated into their ions, even at higher concentrations, are called strong electrolytes. So the strong electrolytes, when they are electrolyzed, what is happening is, suppose I am taking a vessel. In the vessel, I am having aqueous solution of an electrolyte. Say, for example, in general, I write this contains M plus and X minus. And this is negatively charged electrode. And this is positively charged electrode. Now, what will happen? The M plus ion will start migrating towards the negatively charged electrode. The positively charged ion is called cation. Now the cation is migrating towards the negatively charged electrode. The electrode towards which the cation moves is called cathode. This is cathode. And the X minus anion, the anion is moving towards the positively charged electrode because of the attraction between opposite charges. So X minus, the anion is moving towards the positively charged electrode, and this electrode is called anode. Anode. Now, what is happening at the cathode? Cathode, at the cathode, the M plus ion gains an electron and becomes metal 0. So by definition, you have learned addition of electron is a reduction. But the correct explanation for reduction is if there is a decrease in the oxidation number. This is called oxidation number. The charge on the ion, it is called oxidation number. If there is a decrease in the oxidation number, see, this becomes 0 from plus 1. So plus 1 becomes 0. The oxidation state decreases. If there is a decrease in the oxidation state, then the reaction is called reduction. So what happens at the anode? Anode, X minus goes and it releases one electron to become X0, and the electron is released. In the lower classes, you might have studied the loss of electron is oxidation. But in higher classes, you should learn like this. If there is an increase in the oxidation state, if there is an increase in the oxidation state from -1 to 0, there is an increase in the oxidation state. This is oxidation. Why I am telling you this? Number of questions will be asked in this fashion, but you should understand. Say, for example, if a reaction is given where KMnO4 becomes MnO2, what happens to manganese? Then you should know to calculate the oxidation number of manganese in MnO4 and the oxidation number of manganese in MnO2. See, MnO4, potassium being an alkali metal, it is +1. Oxygen, every oxygen carries the charge -2. Therefore, 4 -8. So this is X. Manganese we do not know. All altogether in a molecule, it is neutral. Therefore, X is supposed to be +7. Therefore, the charge of the manganese is +7. In the case of MnO2, each oxygen carries a charge of -2. So 2 oxygens. So this is -4. So as a whole, it is a 0. Manganese, we do not know which is X. Therefore, manganese is supposed to possess a charge 4. So what has happened now? Manganese +7 has become manganese +4. Therefore, the oxidation state is decreased. Therefore, this reaction is a reduction. So anything which undergoes a reduction will be an oxidizing agent. So KMnO4 is an oxidizing agent. It is an oxidizing agent. Why it is an oxidizing agent? Because it undergoes reduction. So anything undergoes reduction will be an oxidizing agent, and anything which undergoes oxidation will be a reducing agent. So number of questions are asked with this idea. Several species are given, and you are asked to identify which is a good oxidizing agent or which is a good reducing agent. So if you want to understand which is a good oxidizing agent and a good reducing agent, you should know an oxidizing agent will have the tendency to undergo reduction, and a reducing agent will have the tendency to undergo oxidation. So what is oxidation? If there is an increase in the oxidation state. What is the reduction? If there is a decrease in the oxidation state. So this fundamental idea you should know. Now, going to the galvanic cell, I will compare the electrolytic cell and the galvanic cell, and then we shall let us continue on the other things. Look here. Watch closely. I take a copper metal. The copper metal is dipped in copper 2+ aqueous solution. Any metal in contact with its own solution is called an electrode. Any metal which is in contact with its own solution is called an electrode. I take zinc metal. Now zinc in contact with the zinc 2+ ion is another electrode. Now there are two possibilities. The copper 2+ ion in solution can get deposited on the copper. There is one possibility. Let me put this is one. Or the other possibility is copper in the metal can get dissolved to become copper 2+ ion. Let me say this is the second possibility. Similarly, on the zinc side, the zinc can be deposited over zinc metal. Let me say this is the first possibility. Or the zinc from the metal can get dissolved to form zinc 2+ ions. This is the second possibility. Now look here, if first possibility is taking place, copper 2+ supposed to gain 2 electron to become copper 0 and to be deposited on the metal surface. If the second possibility is taking place, the copper in the metal has to become copper 2+ ion by releasing 2 electrons. So in the first possibility, the copper 2 plus ion from the solution is sticking onto the metal surface by gaining 2 electrons. If the second possibility is taking place, the copper in the metal will get dissolved to form copper 2 plus ion by releasing 2 electrons. So if the first possibility is taking place, it is called reduction. If the second possibility is taking place, it is called oxidation. It is called oxidation. Similarly, on this side, if the first possibility is taking place, the zinc 2 plus has to gain 2 electrons to become zinc solid, or the zinc solid has to become zinc 2 plus by releasing 2 electrons. So this is reduction, this is oxidation. These two solutions are connected with a salt bridge to form a cell. Now look here, on the copper side, this is taking place. On the zinc side, this is taking place because their natural tendency is to undergo reduction, and this natural tendency is to undergo oxidation. So the electrode at which reduction takes place is called cathode. The electrode at which oxidation takes place is anode. And the cathode should always be written on the right-hand side. And the anode should always be written on the left-hand side. So look here. Here the copper 2 plus is getting deposited by gaining 2 electrons. Therefore, the 2 electrons are abstracted from the metal surface. Therefore, this metal becomes electron deficient and it is positively charged. On the left-hand side, the zinc is getting dissolved and slowly the zinc is getting eroded. So the zinc becomes a zinc 2 plus and goes into the solution. Therefore, the electrode becomes electron rich and this becomes minus. So look here, in the electrolytic cell, cathode is negatively charged. Anode is positively charged. But in a galvanic cell, cathode is positively charged and anode is negatively charged. Therefore, you should not remember that plus is anode and minus is a cathode. We cannot say like this. In the case of electrolytic cell, minus is a cathode and plus is anode. In the case of galvanic cell, plus is cathode and minus is anode. It depends upon whether the cell is electrolytic or galvanic. In the case of electrolytic cell, electricity is supplied to cause a chemical change. In the case of galvanic cell, a chemical change is producing electricity. That is the difference. But one thing is in common, wherever there is cathode, reduction takes place. Wherever there is anode, oxidation takes place. Whether it is galvanic or electrolytic, cathode means reduction will take place. Anode means oxidation will take place. And systematically, if you want to write a cell expression, then you have to write the cathode on the right-hand side and the anode on the left-hand side. So look here. Here also the cathode reduction is taking place. The anode oxidation is taking place. Only the charge is different, but the reaction is the same in the case of electrolytic cell and in the galvanic cell. Now, the natural tendency of an electrode to undergo reduction or oxidation is measured in terms of a potential. That potential is called reduction potential. If the reduction potential is measured at 25 degrees centigrade, and when the solution concentration is 1 molar or activity 1, it is called a standard reduction potential. Now look here. When these two electrodes are coupled, you will get an electricity here. and it is measured in a galvanometer. This is EMF. This is EMF. And the two electrodes are coupled together. It is called a cell. It is called a cell. That is why an electrode is called a half cell. So, two half cells coupled together form a cell. We are able to measure only the cell EMF. EMF of a cell can be measured, but we cannot measure the single electrode potential. Single electrode potential we cannot measure. What is single electrode potential? It is the tendency of an electrode to undergo either reduction or oxidation. If it is the measure of tendency of an electrode to undergo reduction, it is called the reduction potential. If it is the measure of the tendency of an electrode to undergo oxidation, it is called oxidation potential. Reduction potential and oxidation potential are equal in magnitude, but opposite in sign. Only difference is the sign. Now I am going to couple two electrodes, and I am going to write the cell equation, and I am going to write the cell representation, and then we are going to measure the cell voltage, and then we are going to calculate the reduction or oxidation potential. So this training is very important to work out problems in electrochemistry, because you will be successful only when you are making the problems in a systematic manner. Systematically, you should know to write the cell equation and cell representation, and then finally you have to calculate the cell EMF. So up to this, so two electrodes are to be coupled. When two electrodes are coupled, you get a cell, and the cell voltage can be calculated, or cell voltage can be measured. If you know the electrode potential of any one of the two electrodes, then the electrode potential of the other electrode can be calculated. So arbitrarily, the electrode potential, standard electrode potential E0 of standard hydrogen electrode, is arbitrarily fixed to be 0.0 volt. Arbitrarily, it is fixed to be 0.0 volt. What is this standard hydrogen electrode? Standard hydrogen electrode is containing H plus ions, or aqueous solution of H plus ions of activity 1. Activity is nothing but effective concentration, in which a glass tube is immersed, through which hydrogen gas is bubbled. So now the hydrogen, a metal, is in contact with its own ion. Now this is an electrode. A metal in contact with its own ion. Now this is an electrode. Now this is an electrode. In order to have electrical contact, a platinum wire is fixed. Now the hydrogen is bubbled at a pressure of 1 atmosphere. The E0 value for this electrode is 0.0 volt, which is arbitrarily fixed. So with the help of this hydrogen electrode, we are going to calculate the electrode potential of other electrodes by coupling them with a hydrogen electrode, thereby constructing a cell and by measuring the cell voltage. Now look here. The reaction is, whenever you want to write an electrode reaction, the electrode reaction should be written in the reduction order. So H plus electron becoming half H2. This is the electrode reaction. So H plus electron becoming half H2. So this is activity 1 and this is in the gaseous state. So the standard hydrogen electrode is reversible with respect to, what is reversibility? Reversible with respect to H plus ions. With respect to H plus ions. Now I am going to couple hydrogen electrode with zinc electrode. Hydrogen electrode with zinc electrode. Look here. So this is zinc electrode. So zinc 2 plus ion with activity 1. Zinc metal is in contact. And this side hydrogen electrode where H plus ion aqueous solution of activity 1 and a glass tube is inverted. Platinum wire is there for metal contact and the hydrogen is bubbled at 1 atmospheric pressure, and these two wires are connected to a galvanometer to measure the cell voltage, and these two solutions are connected through a salt bridge for electrical neutrality. Now you write the equation. Then you will understand. So on the right hand side, reduction. So H plus electron becomes half H2. This is the right hand side. On the left hand side, zinc becomes zinc 2 plus 2 electron. So on the right hand side, reduction. On the left hand side, oxidation. So if you want to write the cell equation, leaving the electron, you combine all other things. So zinc plus H plus giving zinc 2 plus H2. So in order to balance the equation, you can put a 2 here. So this is the cell voltage, cell equation. Now, the EMF of the cell is E0 or EMF or the electrode potential of the right hand side electrode minus the electrode potential of the left hand side electrode. So right hand side electrode, I have hydrogen, standard hydrogen electrode, which is 0.0 volt. Left hand side, I do not know because I want to find out that it is minus X. The EMF of the cell is experimentally measured here, which is found to be plus 0.76. So what happens? It is plus 0.76. So X is equal to minus 0.76. Therefore, the reduction potential of zinc 2 plus zinc is minus 0.76. This is how the reduction potential of zinc electrode is found out. Now, I want to couple the same thing with copper electrode. You take hydrogen electrode, standard hydrogen electrode, H plus 1 activity, and the hydrogen is bubbled at a pressure of 1 atmosphere, and there is platinum wire for electrical contact, and I'm having copper electrode. So copper 2 plus ion with 1 activity, and copper is immersed, and both the solutions are connected through salt bridge for electrical neutrality, and these two wires are connected to a galvanometer to measure the EMF produced. Similarly, on the right hand side, the reaction is a copper 2 plus 2 electron giving copper. On the left hand side, hydrogen becoming H plus electron. So the overall cell reaction is copper 2 plus hydrogen to give 2H plus copper metal, copper solid. So copper undergoes reduction, hydrogen undergoes oxidation. But here, zinc undergoes oxidation, hydrogen undergoes reduction. Now, EMF of the cell. E cell equal to the reduction potential of right-hand side electrode minus reduction potential of left-hand side electrode. But here the left-hand side electrode, we know it is 0.0. Right-hand side electrode copper, we do not know X. The EMF measured experimentally is found to be plus 0.34. Therefore, the reduction potential of copper is plus 0.34. So, this is how all the metals are coupled with a standard hydrogen electrode to find their reduction potentials. And these reduction potentials are arranged in a series where at the 0 point, hydrogen is there, and below 0, minus 0.76, the zinc is there, above plus 0.34, copper is there, copper 2 plus 2 copper. So if you are able to organize all the elements in this order, keeping hydrogen at 0, it is called electrochemical series. Most of the questions are asked with this electrochemical series, from the electrochemical series, whether this reaction will go on or that reaction will go on, what will happen, all these things are there. Now, what will happen if you couple the zinc electrode and the copper electrode? So various combinations are possible. Various combinations are possible. Is it clear?
Yes, sir.